So at the moment I'm working on the oscillators for the synth, and as I mentioned in the last video, these are all Look Mum No Computer VCOs. I'm not going to do a tutorial on how to make them because there's already a bunch of videos on that channel on how to make these. I've done most of the resistors. What I need to do are the resistors that basically are selected that give you the octave ranges, and the reason I left those to last is because they are essentially working as a voltage divider to give you volt per octave control of the synth. The values of those resistors need to be well matched. So what I'm doing is fairly tedious, is I'm just measuring the value of all of these 10k resistors that I have so that I can come up with 4 that are well matched in value, and that'll give me a nice accurate volts per octave voltage divider. .89. So that's 4 resistors with exactly the same reading on the multimeter, so they can go in as my voltage divider. And I need to do that for all 3 oscillators. Bending the legs so that they stay in place while I turn it over. Make sure they're nice and snug with the board. So that's one board done. I'll do the other 2 and then I'll carry on with the other passive components, and once I get onto the interesting stuff like the Arduino and the chips, then I'll check back in and show you where I'm up to. That's most of the components on this side of the board in now. I'm still missing a few bits, just waiting on delivery. There's a couple of capacitors that just haven't turned up yet, and also the socket that goes here. This is where the CM3340 chip goes, and that's the brains of the oscillator. It's made by a company called Curtis, and those chips are in a lot of classic synths. These chips used to be quite hard to get hold of because the only way you could really get them was if someone had sort of new old stock or they'd been pulled out of an old synth. There are copies that have emerged fairly recently, but Curtis recently started making them again, and actually, once you include postage, I found that the genuine Curtis chips aren't really any more expensive than the copies, so it just seems sensible to get those and actually support the original company. That's currently still in its anti-static bag. I'm not going to touch it until I need to, because they were the most expensive part of the build. I don't really want to destroy them. I think they worked out about $10 each, maybe a bit less. And I couldn't find any sockets that were actually the right size for the Arduino, so all I've done is I've used a couple of headers and cut them down to size. So the plastic's a little bit rough, but it's fine. They'll still do the same job and they fit. The Arduino is there just to sort of monitor the tuning behaviour, and I'll talk about that a bit more once I actually load the code onto it. This socket is so that you can connect up different modules. I won't be using them at the moment. This socket, which is the same sort of connector, is actually where the power will come in. And this socket here connects to a daughter board which will have the jacks, the inputs and outputs. So these 4 resistors are the ones that I talked about earlier that are matched, and they work in conjunction with this part down here, which is a very accurate voltage regulator, and that puts out 4.1 volts. And we've got 4 resistors that are accurately matched, so we can take that 4 volts and split it into 4 lots of volt per octave to get a 4-octave range. There is another power regulator on here, and this puts out 5 volts, and I haven't checked the schematic, but my assumption is that actually goes to the Arduino because that will need 5 volts. It's so beautiful. I'm so happy. Does it work? No. It's missing 2 capacitors. I'm waiting for the post to arrive, and I really hope it does turn up today because I'm travelling later this week, so I'm very much running out of time. That's why I've gone ahead and built this one. I will do the other 2 more slowly and film it. So I'm going to be jumping around a little bit, but look at it. I'm very pleased. It's kind of done apart from the 2 capacitors. I've put the code onto the Arduino. Don't fully understand the code if I'm honest. All it's doing is a frequency count from an analog read. So in theory it's simple, but it's using registries, which I don't know how to do. Everything else is done apart from the missing caps. I haven't put the ICs in yet. I'll just wait till the last minute. Jacks are all in place. What I really like about this is you can kind of tell the bit that I did at lunchtime, because like I say, I'm getting really short on time, and you can sort of tell that the selector switch was done at lunchtime, and you can tell what order I did the pins in, because although most of this is really nicely soldered, the pins get progressively worse as you get closer to my toast being ready. I've finished all the components on one side of the board, so I've flipped it over, and what I'm doing now is the components that will be on what's the front of the board. Before they get soldered in, I need to put the front panel on to make sure that everything sort of lines up nicely once it's together, so that's where I'm at now. Okay, so these are preset potentiometers. These are pots that are adjusted with a small screwdriver, and they'll be just to get the tuning right. So these are things that you kind of set and then leave alone until it drifts, and then you can fiddle them a bit. And what's really nice is I think most oscillators would have these sort of hidden away, but you know, Sam's designers put these on the front, so they're very accessible. And what that's really good is if you go somewhere that's a different temperature to where you normally work, like if you go do a gig somewhere hot, say, everything heats up, things drift out of tune, and you can fairly quickly recalibrate if you need to. I've also got the 7-segment LED display, which is to show the note that it's reading. We talked about the code for that earlier. And I need to fit the pots and the jack sockets. So where are my pots? Where are my pots? So the pots have 2 sets of legs, which confused me at first. I thought maybe these were electrically connected, so that it was just, you know, maybe you had different footprint on your circuit board, but I've done continuity tests between them and they're not connected, so I guess it's you can gang 2 different things that you're controlling from the same pot, I guess. But I only want the inner legs, which are the ones that are closer together, so I'm going to cut the outer legs off. And for that I'm going to use my snips. My snips, which are about 20 years old now. Yeah, about that. And they're blunter than, I don't know, they're blunter than an autistic person when you ask them, do they like your hat? Oh, they're so blunt. It's the amount of force I have to use in my wrist to cut through metal is ridiculous. I really should replace these. Also, it's just insane how long it takes to do simple tasks when your tools are not very good. Okay, that's one. Oh, my pot's fallen off. Just double checking that's the right one. It says 104, which is 100k, and that is 100k. Okay, first pot. So it's 3 connectors and then 2 big legs there just to make sure it's mechanically secure on the board. Next one, cut off the excess legs. Quite like the idea of having excess legs. Why would you keep them though? Oh my god, so blunt. Sorry you can't see all of my face. I don't know where my wide angle lens is, but you don't really need to see my face, but it's probably disconcerting just seeing this bit. Okay, second pot. Oh, hanger on there. Give it a wriggle. That was a bad analogy actually. I find I do like most hats. Hats are good. Big hat person actually. Oh, before I do that, LEDs. 3 LEDs. Now, ideally you use sort of green and 2 reds because these are to let you know if your note is in tune. So we've got a low, middle and high. So it doesn't really make sense to use 3 the same colour, but aesthetically I like the green with this colour scheme. It's fine. You do you. Long leg plus. Now that I'm in my 40s, my eyesight's starting to go, which is a delight. There's 2 issues with that. I've been short-sighted since I was a teenager. That's not really an issue. I was saving up for laser surgery, but I decided to spend the money I saved on the synthesizer, which is very on-brand. So I guess that means I'll be wearing glasses for the rest of my life. But the other thing is, as you get older, your close vision goes, so I don't want the glasses to solder anymore. But I still find it slightly disorientating when I go from sort of close to a bit further away, because normally I'd wear my glasses all the time. Age. Okay, that's all of the things in place except for the jacks, so let's pop this on. Give it a wriggle. I'll just screw the pots down temporarily just to keep everything together while I do this. Actually, fuck it. There we go. Bend the legs just to help them stay in place while I get this sorted. These aren't super easy, they've got really small pads, but if any of them look like maybe they haven't flowed that well, I just sort of very quickly reflow them and give them a wiggle. That's 1, 2, 3, 4 reset pots. Okay, 2, 3 LEDs. 1. These are much easier because the pads are bigger. 2, but not too big. Too big, they sort of suck the heat away and it creates its own challenges. Remember to put your hand over the lead when you trim it so that you don't fire it across the room and possibly into your own eyeballs or someone else's. To get the display in, I'm kind of holding it up with my finger, holding the solder with the same hand and bringing the iron in with the other hand. I just need it soldered in with 1 or 2 pins, and then it'll stay in place, and then I don't have to do this weird juggling act. Obviously you could tape it or clamp it, but it's not really necessary. Go on, a little bit more. Okay, now that's in. I'm going to do the opposite corner just to give it a bit more rigidity. Yep, that's fine, so I can do the remaining pins now without having to hold it. Okay, so next is the jacks, and they live on a separate board, and it connects to the rest of the circuit with some headers. So I need some header pins. Let's see, just break those off. Is that right? No, yes, no. One too many. What a waste. Okie doke. Okay, so where are my jacks? I realise I keep just mysteriously reaching under the table because I'm disorganised and nothing's where it should be. It's a bit like a toddler trying to put shapes into a box. If the toddler was really bad at shapes. Okay, that worked. The pins and the jacks are all in, I think. Just gonna put some nuts on them so they stay in place while I do this. Actually, might as well put the washers on too. Okay. Check that those header pins are actually in. Well, they were, but now they've fallen out. Fuck's sake. Okay. I'm going to solder up the header pins, solder up the jacks, and then all that'll be left to do is the Octave Selectors, which I'm not going to make you watch me solder all of this because that's really boring. Okay, last bit, worst bit. It's the Octave Selector switch, which connects to the 4 equally valued resistors that I showed you previously. And well, you'll see why it's the worst in a minute. But this is a 12-way selector, and we only need 5 of the poles. But it comes with like a washer with a little blocker bit of metal in it, so you can drop that into the right hole, and then you only get the number of clicks that you need, the number of connections that you need. Oh, but before I do that, obviously that's ridiculously long, so I need the enormo scissor to cut through it. It's probably better, in all honesty, to use a hacksaw, but here we are. I don't have a hacksaw to hand, but I do have enormo scissor, which doesn't do a very good job, but never mind. I normally use this for cutting circuit boards, and this is where you sort of fire your part across the room, because of the amount of force needed to chop through it. Christ. Whoops. Yeah, that's good enough. Okay, so on the back, we're going to do centre pin and then pins 1 to 5. They're all numbered, and they're going to go via, well, they're going to be connected using a Molex cable. And the reason I hate doing this is basically the path to my dreams is littered with broken Molex pins. I find them really hard to crimp. I'm getting better at it, but I still have a lot of failures, so yeah. I'm procrastinating, we should just do it. Okay, and we need some cable, but first off I'm just going to tin the connections on the selector switch. So there's the centre. And we also want number 1. Oops. Number 2. Number 3. Number 4. And number 5. Take one of these Molex pins. Now, the important thing about the Molex pin is it's got to be crimped onto the cable, but also it's important not to crush the little clip on the back because that's what holds it into its connector. Take your Molex clamp tool, close the jaws partly, okay, so I've pushed the connector into the tool and I'm just checking that it's lined up really well and that hopefully I won't crush the spring clip in its jaws because that's really important. And I'm going to just tighten it up, another click and check. That might be on the end of the spring clip, maybe not. Then take the cable, push that in. Cross my fingers and clamp. See, no, that's no good. So I'm looking for two things. One is that the clamp, the crimp is actually around the insulation, which it is, and the other is that the spring clip on the back is still poking up, which it isn't, so that's no good. Another failure. See, the trick is closing the jaws enough that you don't then drop the connector, but not closing them so much that you can't actually get the connector in. Okay, I think that that's got the spring clip clear. Let's try. Yes, so the crimp's around the insulation and the spring clip's clear. So if I push that into the connector on the side where the arrow is, because that's checked, that's the right one for the centre pin. Push that in. You hear a click, then you know the spring clip's in, and give it a wiggle. Make sure it doesn't come out. So all that's left to do now is fit the 2 op amps and the actual Curtis oscillator, and then we're good to test it. One thing to check is to make sure that all the ICs are pointing in the right direction. They have a kind of half moon cutout on them, which shows you which way around they go. The smaller of my 2 op amps actually doesn't have half moon cutout, and I originally fitted it backwards on the first oscillator that I did. And then I got very confused as to why my oscillator wasn't working, and Analog Output, who is a person on the Look Mum No Computer forum, very kindly shared a sort of troubleshooting guide. But in the meantime, I noticed my mistake and fixed it, but it's just something to bear in mind. Every chip is marked with where its pin 1 is, but they're not all marked in the same way. If you're wondering what this green and yellow tape is, it's just because the power port and this sort of data port, which isn't implemented at the moment, they use the same sort of connector, and I don't want to accidentally plug power into the wrong thing, so that's all that is. Okay, so I'll pop the chips in. I'm wearing my anti-static bracelet like a massive geek. Then I'll tighten up some things around the front, put the knobs on, and test it. That's it. Okay, so this is obviously completely uncalibrated, but that's a square wave output. You have different octaves, they're all a bit low pitch at the moment because it needs tuning. Pulse width modulation. You can hear that change of character with the change of the duty cycle. We've also got, tune. And you can see the tuner with its 3 lights. Ramp. And triangle. Which is softer than the other two, but that's normal. Brilliant. To be completely honest, this is the second one I made. The one that I've just talked you through has a couple of problems which I need to fix. But I've got 2 working and 1 not working. I'm going to call that a partial win. Where are my parts? Where are my parts? Oh fuck. Christ. Why are you so bulbous? No. Don't do it like this. This is a stupid way of doing it.